Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning.
Morning.
How are you today?
I'm fine. And you?
Oh yes, me too. I'm fine today. In this time, I want to explain about X-ray diffraction. But before I explain about that, let me introduce myself. My name is Nawati. I'm student in Physics Education UIN Sunan Gunung Djati Bandung. Okay, guys. Before I explain about X-ray diffraction, we have to know about the story of X-ray. Next. This is the history about X-ray. X-ray were discovered in 1895 by the German physicist Wilhelm Röntgen. He found that a beam of high-speed electrons striking a metal target produced a new and extremely penetrating type of radiation. Within months of Röntgen's discovery, the first medical X-ray pictures were taken, and within several years it became evident that X-ray were electromagnetic vibration similar to light, but with extremely short wavelengths and great penetrating power. Rough estimates obtained from the diffraction of X-rays by a narrow slit showed X-ray wavelengths to be about this, which is of same order of magnitude as the atomic spacing in the crystal. So Max von Low in Germany and William Henry Bragg and William Lawrence Bragg in England suggests using single crystals such as calcite as natural three-dimensional gratings, the periodic atomic arrangement in the crystal constituting the grating rollings, like that. Next. We can look in here. We have the picture. A particularly simple method of analyzing the scattering of X-ray from parallel crystal planes was proposed by Bragg in 1912. Consider two successive planes of atom as shown in this figure. Now that adjacent atoms in a single plane, this is A, will scatter constructively in the angle of incidence. This is theta. Okay. A crystal consists of a row of atoms that are regularly located. Each atom can scatter the electromagnetic waves that come at it. Okay. In this picture, we can look. This is fields of fields of atom. Yeah. A monochromatic X-ray falling in a crystal will be scattered in all directions, but because of the regularity of the location of the atoms in certain direction, the scattering waves will have in constructive interference, and the others is destructive interference. The atoms in the crystal can be seen in the elements like this. This is in the crystal. Yeah. So these fields like cubes, you know. This is and the name is Bragg fields. And this picture, AB rays, A, B, and D, E. This is a different ray. Come through the crystal and are deflected by Y and Z. Y and Z are different fields. Okay. We'll move to from BC. This is deflected ray from AB, and EF is deflected ray from DE. and distance between y and z named d. We can give the symbol of between y and z, it is d. Yeah, still in this picture, the upper ray is A, and the lower ray, and here is D. The upper ray A will hit point B, and the lowest ray D will hit point E. Because the distance between the two rays must be the same to reach the same ray pace, then we give the BP and BQ limits as the limits for the ideal distance of the same as the top beam. It can be seen that the lower beam has additional distance, namely PE and EQ. In order for the two ray paces to remain the same, this additional distance must be equal to an integral or sum between and multiplied with lambda. Next. From this picture, we get triangle PBE, and triangle QBE. So first we will explain about triangle of PBE. Triangle of PBE, yeah. We can put the theta in here. Sin theta is PE per BE. So PE is BE sin theta. We know from previous slide that BE is same with YZ. So distance of Y and Z is D. So we can change the BE is with D. PE is DE sin theta. So this is as well as the triangle of QBE, as well as this equation. So we can get BE is D sin theta. So additional ray of DEF in this case is PEQ. So we can sum PE and EQ. So PE plus EQ is D sin theta plus D sin theta. So we can get 2D sin theta. So we can get 2D sin theta is N multiplied with lambda. When N is 1, 2, 3 and more, N is scattered rays order. Yes. For today, just that our study, our discussion. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.